Data sets are good evening, friends. So we are now going to have a demonstration on using QGIS for map visualizations. So for that, we are going to use the data sets which will have a spatial data sets that is in form of shape files and along with the attribute data sets. So over here, we are having an attribute data sets which is the DVF files. So let's start it with the first bringing the data sets in our QGIS environment. So I have just opened the QGIS environment and I'm copying the shape files. And along with that, I'm also having a attribute data file, which is a DVF format. These two files have been put in QGIS space. Workspace. Now let's have a look of the what are the attributes which is present in our shape file. So we are seeing that in attribute as a part of attribute of this shape files is just a simple numbers consist of word numbers. So it means like there's no additional attributes information are present. We are also having these attribute data sets, which is a tabular format, and it contains a lot of detailed informations about the uh, each of those words separately. So these data can be prepared as a CSV file or any other file format which you can generate it over here. So it is having a lot of details for each of the word number, or in this case, for each of these polygons. So first what we are going to do is we are going to join the basically the word number which is present in shape files with the attribute data present in tabular formats. So for that, we'll be using the uh, layer properties. So we are just going to open the layer properties. So this right click on the shape files, go to properties, and it will open a layer properties windows. And there's an options called join. So in this join, we are going to create a new join. And this join will be done between the attribute file and correspondingly the field present in our data sets. So we are going to use the word number from our data sets along with the word number present in attribute files. So once we do that, then we will simply press OK, apply. So after that, what will happen is whatever the attribute which was present in shape in the tabular format now gets added to the shape file. So over here we are having an attribute as a word numbers, and all the other informations which was present in the shape files has been added. So if you see the column names, it gives you the column name represents the table name or the table name of this informations, that is attribute underscore ID and so on. So it gives you all the details or the column name present in the tabular format has been added to this shape files. So once we obtain this shape files and it is having all its attribute, now we can start playing with different classification techniques and so on. So let's try out to the classification scheme which is present in this applications. So over here we are having a symbologies options which we can use it for coloring, and we are also having an different options to do or give the color to each of those polygons. So we'll first use the one of the options called categorize. So categorize, as we know, is a kind of nominal data sets. So over here we'll be using a nominal data sets, which is high, low, medium, very low, and so on. So this is the attributes which are present in our table, that is the population density, which has having attributes in a form of names. So there is no possibility of getting any values between them. So let's first see that what happens when we start using it or applying it randomly on the data sets. So as we see that in this case, we are having all the 5 different attributes which gets added to your data sets, and correspondingly each of the data sets gets a unique color for basically unique color based on the attribute as shown in the value field. So over here, we are seeing that we are able to do some kind of classifications based on the coloring and grouping. So as we discussed earlier, the issue over here is that to interpret the informations present in this map, we always require assistance of our this lesion table. So without the availability of these lesions, we will not be able to uh, uh, interpret the meaning of all these different colors. So to overcome, we will be seeing that is there any possibilities there. So let's play around with the other attribute columns as well. So this is just a simple attribute which we are categorizing, which is completely nominal in nature. Now let's use the some other attribute which is numerical. So all the symbols which is given as 1.2, 1.1 are actually the numeric values. So what, since we are having 60 different polygons entry in this map, so we will also have a 60 unique values present in our data sets as well. So these are the different values present for each of those columns. So if I use all these columns to have a separate values and then we do a classifications, then we see that there are a very large number of different colors are present, but it becomes a difficult to interpret and it's a bit more cumbersome compared to analyze with the other earlier cases. So what we can do is we can just try to do some kind of the proper arrangement of these colors. So how we are going to do is we are going to do a sort these numbers according to the values, and then we will try to, instead of having a random colors, we'll try to give a kind of colors which is based on variation of your color saturation levels. So once we apply it, then as we can see, the effect is that the same color as the saturation increases, the value is also increasing. So as you can see over here, so there are lesser values, lesser saturation, but as you move higher and to the higher and higher values, the corresponding saturation increases and the values also goes up. So in this case, even though there are unique 16, total 60 unique colors, but these colors has been assigned in ascending order of the values. So it means we are trying to preserve the property of ordinality present in the data sets by assigning it with the equivalent ordinality of the color saturations. So when we combine these two, then we get a better representation of the data sets. And this representation makes the data set in more representable format, and we can interpret the informations in much better way compared to what we have seen where we were using only hue as an attributes for representation. So that visual structures in that case was only the hue was being used earlier, but in this case we are using the saturation as the color saturation as which is being assigned to these values. So even there are 60 different colors up there, we are able to see all the 60, all the polygons assigned appropriately. And we are able to see that how the values is going to increase or decrease. One very interesting observations which you can make over here is that while doing this visualizations, if we zoom in at the different locations or the core of the cities, then we can make it a kind of interpretations that we are having a cluster over here, which is just very small in size. But there are other spatial cluster which is located at these locations. So this, as we can see that there are at least two places within the city where we are having two different cluster centers, and that if you're able to highlight such cases, then you can look into the history of the city datasets, and based on that, you can make a lot of analysis. Why is it so that this cluster is small, this cluster is bigger, and so on. So such kind of things is being carried out in detailed city study analysis. So, but this just an indications that a simple visualization tools can make some very interesting outcome in term of maps, and later on can help us to form few hypotheses, a few questions which we can test it using different statistical tools and to correct it or to reject those hypotheses. This is just a simple example where we can use visualization appropriately. So once we are now in this case, as we have seen that this is basically each of the polygons have been assigned individual colors. Now let's, instead of having a categorizations of your data set, so it means instead of considering your data to be unique and discrete, let's consider it to be a kind of quantitative data sets. So quantitative data sets, if you're having the data sets in a form of numerical values, then that represents a quantitative data sets, as we have seen earlier or discussed in the last class. And in this case, once you'll be having these numerical value available to you in a quantitative terms, then if you want to categorize them, then you have a very large possibility of putting these data sets into separate columns or in a group. So we have seen a few of them earlier, which is called equal interval, then fixed interval, logarithmic, natural break, pretty break, and standard deviations, and so on. So let's take a simple example of natural breaks. So once we have these natural breaks data sets available to us, let's have a look of the histogram of the corresponding data sets. So as we can see that once we carry out the natural data classification or the classification of your data sets based on the natural break algorithms, then histograms it basically breaks in these forms. So it means like all the values between 0 to approximately 6400 range will be given one color, and between 6400 to 12,000 is being given in another color. So it's basically shows that initially all these are, and the values are basically is almost belongs to a same histogram, but sudden change has been observed, and this break of these histogram has resulted in new class identification or subcategories. Same with the sudden change also in this case, and so on. So as you can see that based on the histogram distributions, the data gets categorized into subgroups, and those subgroups are again being given into color. So let's apply this natural break classifications on the data sets. So if you apply these natural break classifications, so this is basically based on your data values. And as we see that these data values are also having a kind of spatial cluster allocated in a spatial domain as well. So the earlier indication was, which was visible in our earlier analysis, that there are at least two separate cluster was there. Now in this case, we can clearly see that there is a real clusters started appearing during this classification. So it means like based on the subgroup of your data sets, you can have multiple groups, and these groups are maybe spatially co-located or clustered, or they may not be. But in this case, which is we are observing over here, is that it's a spatial clusters. Fortunately, in spatial data science or spatial data science analysis, whenever we carry it out, at that time you'll be seeing that there will be a cluster which is will be visible in almost all the cases. The reason for that is that the nearby values, as per the geography law, the nearby values always will be related. So it means that there will be correlations between the nearby values in a spatial domain, and accordingly that gets reflected in your histogram. So if you apply a simple natural break or classification on your histograms, that can also exaggerate or show the spatial clustering in the images. So based on this, we can do classifications and we can represent the data sets in this way. So this basically shows that the inner part of the city is having a lot of high density surrounded by a lesser density, and at the periphery as you go around, so you see the density of population density getting decreased. Where in the other cluster, it is not starting from very high density, but this is just starting from the medium to higher range, and accordingly the new cluster is being formed. So another important things which we can interpret from such an analysis, that the or hypothesis which we can make over here is that all the higher density values may be the older part of the city, and the newer cluster which has emerging is actually a newer or the added part of the cities. So such hypothesis can be made and tested historically with the other evidence, and that can again give a lot of historical perspective of a city. So this is just another example how we can extend the analysis and make few hypotheses and later on do a testings. So let's now try out with the other type of classification. So this is natural break. So in this case, we are seeing these values are very diverse, like it is not having exact numbers which we like to see in our map. So for that, the people have given a kind of pretty break options. So this basically lets you to have classification based on nearby rounded values. So you can create a classification based on this and so on. Then there's also an options for creating a quantile based approach. So it means like you'll be having a quantile classifications techniques, like first 20%, next 20%, and so on. So let's apply this classification scheme as well. So as you can see, the outer periphery of the city is having 20%. Then as we move inside of the core of the city, we are having another 20%. So that is coming in the next level. And in between, the appearance of around the subcluster has also started appearing. So next 20%, another 20, next 20%, which is having orange color, is being shown here. The red brick color which you're seeing is the next 20%, and the very core of the city falls in the top 20% of the data sets over here. So these two are again indicating and that there are two cores present in a city. So this basically gives you all the colors which is being used or represented in our in the classifications table, that gets also reflected in a map forms, and each of them 20% of the data sets are using all the color tables which is shown over here. So there are also classification scheme. So this just to bring the context over one more very interesting facts, that in this case, as we can see, that top 20% is there, surrounded by the next 20% or the another next 20%. So it's like it's a kind of layer by layer city uh, uh, wards which we can observe over here. Now let's do the classifications techniques, which is the standard deviation based approach. So standard deviation based classification will always have an equal number of or the even number of classes, because +1 -1 standard deviations. So as we are having in this case we are having four different classifications or the four standard deviations of the classes which we created over here. So as a result of which we can see it after the classifications, we can see that the highest level of standard deviations, that is being represented in the dark color. Then it is being followed by, in some cases, the surrounding very extreme or the other side of the histogram or the standard deviation is also being shown in this case. So it's a kind of case where it represents that there would have been or something might be there which acts as a barrier in this region, that just next to the top or the highest level of or in the highest standard deviation, that is the +2 standard deviations positions, the value is having some neighbors which is at negative side of the same scale. Standard deviation is present. So these kind of things can basically show or reflect that there is a kind of disparity, and this disparity is very huge in this case. So if such disparity is existing, then in those cases we can look into the reason for that. That why suddenly the at the positive standard deviations data sets are just being neighbored to a negative sides of standard deviations. Theoretically, it should not happen, but it is being observed in this case. So we can look into that, and that again can reveal a lot of very interesting facts, that why is it so, and so on, and that can again give the or that can make a city analysis in this case very interesting. So this basically shows that how the data-driven classifications approach can help us to look into spatial data sets and try to understand the underlying effect of different classification scheme. So you can try out the other approaches. You can have the other uh, classification schemes. You can carry it out. And like in this case, you can have an equal interval, which you can create, and other classification schemes you can carry it out. So let's now go ahead with I'll just, for the time being, I'll just take us one of them, which is natural break classification schemes. And after carrying it out, the basic analysis of your data sets, at the end of your GIS activities, you would always like to produce some kind of maps. To generate a maps, the QGIS provides you the basically a mechanisms where you can create maps of different layers. So how do we do that? So we will be starting it with the layout manager. So generally, to create a layout manager, there are multiple ways of doing that. But first, let's go from project and create a layout manager. So once you create a layout manager, if there's no layout manager is available to you, or is pre-existing layout is not available, then we can just create a new one. So I'll just create a new one. So this basically gives you a layout of on a paper on which the maps can be generated. So at first stage, you can think of this is a simple representation of your paper and how will it will look like on whenever any content is will be put in. So you're having a different options. This is the scales which is being given. So this basically gives the scale representation of your paper. So you can do different setting of these papers like or you can also set the different output product output. For example, what should be the DPI? So you can set the DPI values over here. Do you want to print it as a raster or a vector files? That's basically you can pass on. You can use it and a lot of other properties, layer properties is being given. If you're having any reference map, you can use them as well. So there are multiple, basically the properties which is assigned to the layout manager, or this is just a simple layout. You can also add different grid lines, like if you would like to add grid lines of some spacing, let's say I'll just say 2. So you can add it. So those grid lines will appear like on the top. You can see it over here. So this started appearing. So there might be a multiple informations which we can add it onto this paper. So for the time being, we'll just ignore the grid line options because that is currently is not required and we have to take it as per the data sets. So once you're having this layout manager available, then what you need to do is there will be a lot of tools which helps you to bring your data sets from your QGIS workspace to a layout manager. So you can do that with the help of all these tools which is available on the left side of this map layout sections. There are also options to add it all these elements from the top, so you can add it as well. So currently I'll just add a map. So map is nothing but whatever information which was visible. If I just click on and wherever in the space on the paper we want to represent it, we can just properly arrange and we can put it over here. So in this case, we're having basically added. We have added these maps. There's an also different options associated with this properties like layer options you can create and the other colors and other variations. If you want, you can add it over here. But for the time being, I'll just show that these maps you can add it the way at the scale whatever was present in your visualizations case or in the actual workspace. If you want your maps to be put in a particular scale, you can put it over here. So this at a specific variation, if you want, you can set it and accordingly that will also get added to your map. This information gets added to on the map layout. Then in this map layout, the other map elements you can add it. So I'll just quickly go through that how to add different map elements. For example, if you want to add legends, so that legends can be added. So these legends will be made available. If you want to have north arrow or north arrow elements, so those elements you can add it. If you want to insert a scale bar, you can do that with the help of scale bar elements. So that scale bar, you can add it. You can also add the titles and other thing. That's will basically an label adding. So you can put an So you can basically make modification of this. There you can say Dehradun, you can play with the different kind of fonts, options, colors, and so on. So you can use the other options which is available like justifications, position, rotations, and so on. I mean, there are multiple properties to play around with to make it more neat and clean. So I'll just skip all those options. So it means like you can add the multiple map elements appropriately in your map layout. So once you have put all these elements and arrange them as per your requirement, and then later on what you can do, you can export it as a format in the image format. So you can export it as an image or in other vector file like SVG format and so on. So in this case, we are having all the images. There's no raster elements. We are having a vector elements. So which gives an options to export the images in SVG format so that even if you enlarge it for a printing purposes, it is not going to gets impacted. So that's possibility is there. For the timing, let's say we'll just export it as a format in a text, and then you can save it in multiple format like BMP, JPEG, and so on. So for the time being, we'll just say as a test, we are going to save it. Now there's an option of having an DPIs. So higher DPIs means printing quality will be good. And even if you enlarge them, there will not be any impact. So generally DPIs and other size would be based on your requirement that do you need to have printed on a A4 size paper or you need a very large display outside in a stadium or some kind of very large billboards and so on. So based on those requirements, you're going to have you can set these resolutions. So for the timing, I'll just take the default test DPI, which is being put in over here. And as you can see that it just exports, and after exporting, we'll have this image available to us. So this doesn't look good over here, but I think from the concept point of view, this gives a very good idea about how and what are the different potential for generating the maps from the geospatial datasets. So with this, I'll be stopping my demonstrations. So any questions, if it is there, I'm ready to take those questions now.